Okay, so today we started looking at bivariate data, and we're going to look at ways of displaying when we're looking at bivariate data. So we could have two. It's when we have two categories. So down here, we're now going to look at when we have a numerical variable and also a categorical variable. So here you can look at it, and a way of displaying that is like a parallel box plot. So you can see here you've got the age groups there. So that is age groups. What type of data is that? That is actually categorical, because see how they're categorizing it between 20 and 29, so that makes it categorical data. So that's the age group. So just you might want to write that's categorical, and it's ordinal because obviously you do have younger to older. Then so that's the categorical data. Now down here they're just quoting what their the average salary or whatever is of that thing. So the salary is the numerical data there. And that one's probably, we'd just say discrete, because it's just a counted number. Okay, so salary is a set amount that someone gets per year. Okay, so here what we're going to ask, is there a relationship between these two variables? Can we say they are associated? And we're going to say yes. Now the most easiest way to comment on them is we're going to say yes, because can you see the median increases, doesn't it, with age as well? So we could say, so that's one way we could say there's an association. We use the medians. So here is an example of the report. So from the parallel box plot, we can see the median salaries increase. So there's the comment of change with age group, and then and then they're going to quote the stats, which they do right there. And this is an indication that the typical salaries are related, or there's an association to age group. Okay, so if there's any difference, you can say they're associated. So it doesn't have to be just the median. So look, if we look here, we could do the IQR. Okay, so the IQRs are these boxes, and if you notice, they get bigger as we go along as well. Okay, so you could quote the same, and there's an example of us quoting the change in IQRs. And then the other thing you could quote on is the shape, because that's another thing that we notice is changing. So I'll just rub that stuff out. So with the shape, you can see that this one starts off symmetric, and then it gets more and more positive skewed. So that's what we're saying. The easiest is to say the median, yeah? So if you've got a change in the median, just quote that one, because you can just quickly see it and quote that one. But if you have to, they might say use something else. There you go. All right, so here's an exam question. So let's go through this. So the box plots below display the distribution of maximum daily temperature for the months of May and July. Now it says first mark was to describe the shapes of the distribution. So we look up here, we've got July first. So July up here, and that one looks to me to be positive skewed. Yes, the box at this box is smaller. So we're going to say positive skewed with outlier, because this one has an outlier, yeah? So with outlier. If you don't write with the outlier, you won't get the 1 mark. So any little mistake here you won't get the mark. So for May, I'm going to say it appears symmetric. Now you can write with no outliers, you won't get penalised, and you can just write symmetric, that's fine. As long as if there is an outlier, you've got to comment on it. So here the other thing is to determine the upper fence for the July. So there's just a few people yesterday said they were might not have been in this class, but a bit scratchy on the upper fence scenario. So the upper fence, remember there's these fences that if the number's above it, it becomes an outlier. So there's definitely an outlier there for July. So what we do, write the formula, upper fence is Q3 plus 1.5 times the IQR. Okay, so Q3 you can read off. So for July, if I come down here, that looks like 11 plus 1.5 times the IQR. Now the IQR is the Q3 minus the Q1, and Q1 is 8. So that would be 11 plus 1.5 times 3. So what does that equal? So 15.5. Okay, so any number above 15.5, which was just here, and that's why that, whatever that one was, it was above it, is an outlier. Okay? If we were to say if there was, are the two variables associated? Okay, so what are the two variables associated? And the two variables are the month, that's the category, and the temperature, that's the numerical. Okay, so are the two variables associated? I would say yes, as May's median temp is higher than July with, I'm just going to say, what's that, 14.5 degrees Celsius for May, and what's that one, 9 degrees July. Okay, so that shows there's an association because there's a change. Okay, so with this one, here's another parallel box plot. Okay, so the box plot shows the distribution of mathematics and the results on the maths and the history exam. So here's these two are the categorical data, and I guess the score or the result is the numerical. Okay, which of the following is not true? For history, any score less than 30 would be an outlier. So you need to double check that. So how do you check that? You could check the lower fence. So the lower fence is Q1 minus 1.5 times IQR. So we're talking about history. So history's Q1 is 50 minus 1.5 times, and it looks like 70 minus 50. So that equals 80. Was it? No, sorry. What am I doing? 20 even? Is it? That's 20. Well, yeah. So 30. So it's 20. So anything lower than 20 is an outlier. So which of the following is not true? For history, any score less than 30 would be an outlier. That is not true. That's not true, is it? So here, we've already got the answer. So we could go on and check. Let's check the others just to practice. The median history score was greater than the median mathematics score. That is correct. 25% of the history scores were less than 50. That's true too, because remember these things are all worth 25%, sorry, each one of these things. Okay, 75% of the mathematics scores were greater than the lowest history score. That's true because we've got 25, 25. See, here's the lowest, 25, so that was true. And 50% of the history scores were greater than 60. That's true because those two make up 50. So we've checked.